Hey, what's up, guys? I just wanted to give you a quick little introduction to trigonometry, and then we'll work through a couple of examples today. So trigonometry is all about these right-angle triangles, particularly when we're given an unknown angle, which we'll call theta, and a couple of other sides. We'll talk about these sides here. You might have used these as A, B, and C if you've done a bit of Pythagoras before. But I'm going to talk about how we change those up for trigonometry. So trigonometry is particularly revolving around three ratios, and then there's a few variations on those different ratios. We have the sine ratio, we have the cosine ratio, and we have the tangent ratio. And it's about how these sides interrelate to each other and the angle associated with those. Given this unknown angle, if we get the sine of an unknown angle, then the opposite side divided by the hypotenuse will actually give us that result. Opposite over hypotenuse. For the cosine of an angle theta, we actually use this other side, the adjacent side, and divide it by the hypotenuse. And there's only one other option left for us with the tangent ratio, and that's using the opposite side divided by the adjacent side. There are options where we flip these over, but we're not actually going to cover those ones in this one. If you want to look more into that, we can probably cover that another time. Just let me know. So I've got for you a four-step process that I think you can apply to any trig style question. Number one, you need to identify the ratio that you need to use. So identify whether you're using sine, cosine, or tangent. And you use the phrase so, ka, toa to help you remember each of these ratios. You can see the SOH, CAH, and TOA to get those through there. After you've worked out which ratio you need to use, from there it's a simple fact of just substituting values. So if your theta is the unknown, then you substitute in the other two, the lengths that you know. If you don't know one of these lengths, maybe there's an x next to it, you're probably given the angle in that case, so you should be able to solve it from there. We might do some trickier ones later on where you've got a couple of unknowns in there. The third step you're going to be doing is obviously solving for that unknown, because whether that's theta or x, but whenever there is an unknown, obviously in maths we want to work that one out ASAP so we can move on to the next idea with that number. And the last little thing, pretty important, is to review your answer and make sure it makes sense. Because if you've used the wrong, if by any chance you've used the wrong ratio, this answer at the end here isn't going to make any sense, and it's going to be pretty obvious. Make sure you use the correct units, whether you're using degrees, radians, meters, centimeters. Work that out as we go through as well. All right, boys, so we're looking at using trigonometry to calculate side lengths here. This is worked example 12, exercise 5.5. A right angle triangle here. The first thing we need to work out is we probably want to label these sides and work out which side is which. The hypotenuse is obviously the longest side and directly opposite the right angle. Here's our angle. Our unknown here is opposite side, and the adjacent side, well, we don't really care about that at the moment. So we're using something that relates to the opposite and the hypotenuse, and if you remember, so, ka, toa, you can see opposite and hypotenuse are in the sine ratio. So we are doing sine theta is equal to the opposite over the hypotenuse. From here we just substitute in values. The opposite is x, the hypotenuse is 6 centimeters, sine theta is 35. Trigonometry involves a little bit of algebra to work this one out, so we're going to multiply this side by 6, which means we multiply this side here by 6 as well I can rearrange this formula to have x is equal to 6 times sine 35. Therefore, once you key that into calculator, you get that x is approximately equal to 3.441 centimeters. Next step is using trigonometric ratios to calculate an angle size. We're going to use the same ideas that we've just worked with. First thing we need to do is to identify which of these sides are in relation to this angle. So again, this is the opposite side, this is the hypotenuse, and this is the adjacent side. Again, so, ka, toa, and we're looking at, again in this example, we're looking at the sine ratio. So we write the rule that the sine of any angle is equal to the opposite divided by the hypotenuse. We now fill in our values. So we've got most of these except for theta. So the opposite is 3.5. The hypotenuse is 5. So this is going to be 0.7. So we're looking for the arc sine of 0.7. And we don't need to write that as an exact value. In this case, we want to round it to the nearest degree, which is, in this case, 44 degrees.